What'd you make?
Oh, that's weird.
Alright, so we have log base square root of 9 of 81. What is the square root of 9? Can we not say that log base 3 81? It's the same thing. Okay, so we've got now, take this logarithmic form, put it in exponential form. So we have a base of 3. The sum y power equals 81. I need to break this 81 down into a base of 3. Right? Well, there's 27 times 3 not giving you 81.
Yes.
All right, so we break this down and make this 27 and 3. Well, that's 9 and 3. Well, that's 3 squared, and then 4 3 is going to give me 81, correct? So I've got 3 to the y equals 3 to the 4th. Same basis. Drop your base, set your exponents equal to each other. Y equals 4. That's your answer. Yes, ma'am.
Is my test going to have the same type of problem?
Yes, ma'am.
Just different.
All right, questions on 1. Did anybody miss number 2? Number 2. We've got the common log of 0.001. Now, if you remember back, we cannot use decimals when we're talking about logs. But we can take that decimal and write it as a fraction. Correct? What is that decimal as a fraction? 1 1,000. Correct? So 1 over 1,000. That's going to give me 0.001. So this is like saying the common log of 1 over 1,000. Well, the common log has a common base of 10. So we have 10 to the y equals 1 over 1,000. Well, we can say 1,000 is going to what power? 10 to what power is 1,000? How many zeros are there? So 10 cubed is 1,000. So 10 to the y equals 1 over 10 cubed. But that 10 cubed is in the denominator. What property do I need to understand to take that 10 cubed to the numerator? What? Kinda. What do we need to know about exponents? What type of exponent will take it from the numerator to the denominator or the denominator to the numerator? Negative exponents. Remember? We had the property, if you have x to the negative n, that equals 1 over x to the n. We had that property, remember? So, if I want this in the numerator, we have 10 to the y equals 10 to the negative 3. Two bases are the same, drop them, set the exponents equal to each other. What is y equal? Negative 3. Questions? Hey, you say you missed it? Yeah. 3. Everyone.
Yeah.
Everybody miss number 3?
Yeah,
Get it right?
I missed number 3.
That was a homework. Number 3 was a homework question. We did that one on the homework. Right? The 7th root of 4. Log of the 7th root of 4. Or excuse me. Log base 7th root of 4 of 64. Now, we talked about taking a radical and putting it as a rational exponent. Do we not? Okay, let's take it, put it as a rational exponent. The 7th root of 4 is 4 to the what power? 1/7. Because this 4 inside the radical, or whatever's inside the radicand inside the radical, is raised to the first power. So we have 4, because we're taking the 7th root all that raised to the y equals 64. Well, when you have a power raised to a power, what do you do with exponents? Multiply, correct? So 1/7 times y, 4 to the y over 7 equals 64, correct?
Yes.
What is 64? 4 to what power gives me 64? I can say 16 times 4, and then 16 is 4 squared. So 4 squared times 4 is 4 to the third power, or 4 cubed. So we have 4 to the y over 7 equals 4 cubed. Well, your bases are the same, drop them, set your exponents equal to each other. How do I solve for y? Multiply by 7, you get y equals 21. Try number 5. Try number 4 now. After you've seen this one, try number 4. If you missed number 4, try it real quick. You don't have to do responsibility. Alright, we got log base 36.
It's not the same thing.
Oh, the fifth root of 6.
Okay, yeah, no, I get
Sure.
it.
Alright, so now, here's my base. 36 to some y equals 6 to 1/5 because of rational exponents. Alright, so now, this 36 becomes 6 squared. It's still raised to the y of 6 to the 1/5. Exponent raised to an exponent, multiply, so we have 6 to the 2y equals 6 to the 1/5. Bases are the same, drop them, set your exponents equal to each other. I can either divide by 2 or multiply by 1/2. The easiest thing to do is multiply by 1/2 to get rid of that 2, go down with the y. So, y equals 1/10. Yeah.
Yeah. I just don't understand how you do it. It looks so easy as you do it, and then like your mind blowing when you look at it. By yourself.
Number 5, now number 5, you don't have to work anything. If your big base equals the, if you're raising a base to some logarithmic exponent, if the big base equals a small base, then the answer is whatever you're taking the log of. So number 5, the answer is 1. Does that make sense? If the big base equals a small base, the answer is whatever you're taking the log of.
Why did I think that 1 equals 0?
Anything raised to the 0 power equals 1.
So I just got those two swapped around.
And I didn't do the same.
Do what?
It's not big base and small base will be the same.
Maybe. You might not even have one like that.
No, you said I was going to. What do you mean by this right here?
You gotta do the power rule.
Okay.
The power rule takes the exponent and puts them in front.
Oh.
Number 6. Natural log 48. Alright. I'm putting this in terms of natural log 3, natural log 4. Now I understand that we did not do one like this on review. However, this was the first thing we done in the homework. Think back all the way to the very first homework, this was the first thing we did.
Can you remember that?
This was the first thing we done in the notes as well.
What are you talking about?
I can't remember.
We turned in a review for a test grade.
Yeah, that's the
Yeah,
thing
you
that I
finished
said
it?
I just hadn't done, but I did have done.
I remember.
So now, look at 48. Can we not break this down? I need it in terms of 3 and 4. 12 times 4. That's 3 times 4. So 4 squared and 3. So 48 becomes the natural log of 4 squared times 3.
How did you, where did you get 3 and 4 like I have to? Oh, okay, never mind, it's an expression, never mind.
I got one question.
Well, right here, I've got to multiply all these numbers together to get 48. Now, once I know that I have 2 terms being multiplied together, use the product rule. So you got the natural log of 4 squared plus the natural log of 3. The power rule brings that 2 out front. 2 natural log 4 plus natural log 3.
That's what I didn't put the 2.
All right, I'm going to talk about 7 in a second. Word number 8, though. Do what?
So I got that out. If I didn't use 3 on it.
It's 12 times 4 is 64.
12 times 4? 48.
So 16 times
Good.
So I'm going to the city on this.
Singing. This is an A+ test.
Absolutely. Did anybody get an A plus?
Huh?
Anybody get an A plus? Does anyone ever get an A plus this class? Dude, I'm going for an A plus.
Pre-Cal.
Just kidding.
I lied. Plus last year. Like somebody made 120 on the first test last year.
Carly made 116. She said, "Are y'all doing this?" I said, "No, we didn't even cover that."
It's not believable.
Y'all were doing two totally different things.
No, they did not. The only thing they had difference on their first test was the bonus.
No, it didn't look like anything.
Continuity, domain and range, all the time.
When do we go another grade to our first test?
I already knew that.
No. You never go to.
Oh, well. Oh, I got it right there. I'm sorry.
Who want to see
I
that?
just want to know what I have in this class.
I just want to know what it is. Have you?
Simple reason that it packs so much iron. Because y'all love decimals, correct? It's the
Correct.
You love decimals. However, this problem's given to you in decimals and you have to turn it into what you hate the most, which is a fraction. And it just makes my day. Alright, so how do I turn 2.25 into a fraction? What is 0.25 as a fraction? 25 100ths and simplifies to 1/4, right?
Yes.
So we have the natural log of 2 1/4. Well, I don't like mixed numbers because they look weird and they've got a big number and it's fractions, and that's just not fun. Alright, so let's make everything improper. Alright? And when we turn this thing improper, we don't use some slang jargon term called around the world, because I don't know what that means. So what we're going to do is we're going to say the denominator times the whole number plus the numerator and all that over the denominator, which is exactly what we're doing. Around the world, don't tell me what we're doing.
That's just a saying to know that.
Exactly.
We
2
have.
times 4.
But
You
we
know
don't
what?
even
You know
know.
what it's going to say on the ACT? It's not going to say, "Hey, use around the world here."
What is it? What is it gonna say?
It's going to say, "Make this improper."
We're going to say,
Look, you're not even going right. You're going halfway around the world because you stopped.
Yeah, it's not even right.
It's like having to, it's like going around the moon.
No, it's just what we grew up learning.
Bushly.
That's what.
You
That's
remember
not
this?
bushly.
You remember this?
Yeah.
Ask our teachers.
So we have the natural log of 9 over 4. All right. Now we have the natural log of 9 over 4. Okay, so we have a term in 4 right here. Okay, we've got a 4 term already. We've got to make this 9 something with 3's. So what is 9 in terms of 3? 3 squared. So now it just becomes the natural log of 3 squared over 4. This is a quotient, once again. So we subtract natural log of 3 squared minus natural log of 4. The 2 comes out front. We get 2 natural log 3 minus natural log 4. Now we're done.
Okay. Number 9, go.
Absolutely.
Does a dot name have to
Yes.
figure that out?
Like, it is really easy.
I know it's really easy, Bill. Oh, that's why.
It would be, but I don't remember.
All right, number 9.
What, come on, probably gonna say compress or something.
Do what?
I like this probably to be like compress. Instead of expand.
It says expand. There's also a condense. There's a condense on this one too.
I expanded that to the best of my knowledge.
All right, number 9. We've got log base 3 of the 4th root
I knew
x squared y cubed z to the 5th. All right, now, do we not say we're going to take this radical and put it in terms of a rational exponent? Do we not say whatever the radicand is raised to is the numerator over whatever root we're taking, which is the denominator? What? Same thing. We got log base 3 of x, that's raised to the 2nd power over 4th root. What's 2 over 4 simplified? 1/2. So x to the 1/2. Y is raised to the 3rd power, taking the 4th root. Z is raised to the 5th power, taking the 4th root. All right? Now I can expand. Now I can easily expand. I use the product rule. I'm going to take log base 3 of x to the 1/2 plus log base 3 of y to the 3/4 plus log base 3 of z to the 5/4. What's the only thing we have left to do? Move the exponents to the front. So we get 1/2 log base 3 of x plus 3/4 log base 3 of y plus 5/4 log base 3 of z.
We need to do a condensing one.
You want to see what it is?
We're older. Do I need to stop the video?
And it's over. We won't finish this